So we're going to continue on with soil, and we're going to talk about different properties of soil that they have and how this really impacts their environmental issues, what they are, all those type of issues. So soil pH. So you know what pH is. We've talked about acid mine drainage. We've talked about high pH, low pH, and everything. So the pH of soil is a very important factor. This is one thing that controls a lot of the different nutrients that are available for plants. It's one of those parameters that's actually really hard to measure. If you go into the soil science literature and you look into it and you're like, okay, so how do we measure soil pH? Which it's so important, but it's actually hard for us to measure. So there's different types of probes you can put onto the soil, or do you make a soil water mixture and then you measure that liquid, because usually we're measuring in a liquid. There's a whole bunch of different methods out there for doing this. So it's actually a really interesting thing is like, how do you actually measure if you have acidic soil or basic soil? Certain things we do know that, are very acidic out there. So like conifers will, their needles will make the soils very acidic. When you have very acidic soils, you leach a lot of the metals. So remember we talked about high pH or very low pHs and how heavy metals become mobile in water? Well, the same thing happens in soils, is that if you have very low pHs and you have acidic soils, you can pull a lot more leaching of these metals, these aluminum, all these things from the soil. So the pH controls the soil microbial activity. There's certain types of microorganisms that like low pHs and some like high pHs, but they generally like it around neutral. And their nutrient exchange, so like we can look here at nitrogen. So nitrogen is really green here. Here's pH of 7 down here. So you can see nitrogen likes it right in the middle, but if you get too much on either side, it really doesn't do well. Phosphorus likes it, but then again, they like it really, really alkaline, but very few plants like it there. Potassium likes it neutral, sulfur likes it neutral, calcium, manganese likes it a little bit more slightly alkaline. But then when we start to get more into acidic conditions, that's when we're going to release that iron. So we can see that coming into there. Manganese, boron, copper, zinc. Remember, these are all those heavy metals will start to be released at this thing, and molybdenum are really basic. So we can talk about what nutrients are needed for the thing, for the plants, and what are needed, because certain types of plants need certain types of things. It impacts the gaseous exchange, so the roots are giving off gases in there, and how much activity there is. Chemical degradation, so microorganisms and things will degrade. A lot of we'll talk more about organic materials in a little bit, but how do they degrade those chemicals that are in there? And this will impact the cation exchange capacity, and we'll get more into cation exchange capacity in there next session, but cations are positively charged, if you don't remember. And this is exchanging of those cations. Remember we talked about ion exchange for water treatment. We're going to talk about cation exchange capacity for soils and CEC. So the pH, let me move me over here. I'm going to be over here for the rest of the lecture. Let's see, I'll put it about right there. Okay. So the pH over here, remember that we have alkaline conditions. Usually you find this in arid soils. So if you go out to the desert southwest, when I lived in Arizona and I studied soil science out there, we had much more alkaline soils. We would have, in some areas, we would have usually pH greater than 8. So this is more alkaline plants liked that system out there. It was actually really interesting is that, it's a very different types of soils that are there. I was at the University of Arizona, and we would have this mountain. It's Mount Lemmon, that's right near the university. And when we studied soil science, we would go up the hill, and we would have these different soil pits. And we could look at different types of soil just within a very short reach of the university. Unlike here, where you've got mollisols and alpha sols. That's it. Range of acidity, weathered soils. So when I lived in Tennessee, we had very highly weathered soils. Very old rocks there, and very highly weathered, and this is in the southeastern part of the United States. This is very common out there, and so when you see them, that's when you see those red soils and red there's actually songs written. If you listen to like certain types of music, there's songs written about the red soils and everything like that. And that's what happens when you get the acidity into there. The coastal plains usually have pHs of less than 5, and this is where and then when you get up down to these things, it becomes too acidic for a lot of plants. If you come too high, you become too basic for plants. And so plant growth really likes to be in this middle part. Different types of plants will grow in different areas, but this also impacts what kind of things get into our water and our water supply and our whole environmental system here. Soil pH, like I mentioned before, the methods vary widely. And you can't see, trust me, and what you should do is, if you're ever doing a research project on this, is that you should stay with the same method so that you can compare and contrast your results with everything else. So as long as you're consistent, it's better. The measure of the direct concentration of H+ ions in the soil. So there are direct concentrations, like I said, you can put there is some dry probes where you put it on there, but they look at that H+ concentration. Usually you mix some sort of ratio of soil to water in there. And then the buffer pH measures both the H+ ions in the soil solution and what's used for the cation exchange capacity. We'll talk more about cation exchange capacity in there. And then this really impacts, like for farmers, is do you need to add lime? So limestone, it's the more basic sides of things. Are you adding lime? Now, it's not limestone. I should clarify that. It's not limestone, but think more basic type of thing. So if we have that, and you all know that pH is represented by the negative log ion. So one of the things to always keep in mind when we talk about pH is, the difference between 7 and 8 is a tenfold change. This is a tenfold difference in each one of these numbers. So it makes a big difference when you go from 7 to 8. It's tenfold. Factors affecting the soil pH is the parent material. So what are you starting with? The parent material, remember we talked about soils being formed from, your basic materials, and then it creating over thousands of years. So whatever that rock, that R horizon is, will impact it. How much rain and precipitation do we have in the area? So a lot more weathering can occur that way. If you're applying nitrogen, so nitrogen is going to impact it and change the concentrations and the pH of the soil. What type of crops are you using? So certain types of crops will, because when you have the root systems into your soil systems, they will have materials that go out into the soils, and they'll change the pH of the soils. So what types of crops you're using will impact it, how all the things happen into there. So these are things to take care of it. And then organic matter breakdown. Now, we've talked a lot about, accumulation of organic materials, and organic material will break down, or we call it degradation or degrade. When it breaks down, it usually forms acids. Organic acids are formed when these things have. So usually when you have degradation, your pH will decrease. Same thing when we talked about teeth. This is like the organic material that's left on your teeth. The bacteria eat it. They create organic acids, and it eats away at your teeth. Same thing happens here. And so when we have organic matter breaking down, we start to see more and more acidic conditions. So think about when we talked about the oil spills that happen. Think about, we have a lot of really black soils around here, those mollisols that we have around here. And so since we have those mollisols that are in this area, that organic material there is breaking down. And so we can kind of see slightly more acidic conditions as that's breaking down. Our organic material, we'll get to it. Getting ahead of myself. Just too many exciting things to talk about with soils. So one of the things that when we talk about acid rain, rainwater is naturally acidic. So if you went out on like a day-to-day where it's raining outside and you collect rainwater, you're going to find out that rainwater is naturally acidic. It's usually got a pH about 5.4 to 5.6. Why is it acidic? Because of the CO2 in the atmosphere. That CO2 in the atmospheric, atmospheric CO2 makes a weak carbonic acid, and so it makes our pH is 5.6. And what did we talk about when we have more acidic conditions? We get more weathering of our soils. So this is one of the things that's happening in there. As we increase the carbon dioxide, we're going to make the rain even more acidic. which will weather even more. As we have these fossil fuels and everything into there, they're creating also, if we have sulfur coming in, so high sulfur. So we talked about, remember, oils and gases and stuff like that, sweet crude versus sour crude and removing the sulfur. But if we don't remove the sulfur, we put that sulfur into the atmosphere, that sulfur interacts with the oxygen and creates sulfuric acids. That also help to lower the pH. So fossil fuels added to acid rain, but it requires only 25 pounds of limestone per year to neutralize it. So we can neutralize that acid because these are sulfuric acid's pretty strong acid, but we can also neutralize it. So, but you know, we don't want to just keep adding stuff to our soils and stuff like that. And acid is also produced by nitrogen applications, so we produce nitric acids too in the atmosphere. So these NOx compounds. So we can see that the rain becomes even more acidic, especially when we're downgrade, and which weathers our soils even more. I just wanted to show you some things about clays here. Clay minerals are a very important part of soil. This is what a clay particle looks like. So clay magnified by about 1600 times, and you can see how platy it is into there. It's a very platy, and you can get inside between these plates are all these cations, and this is going to lead us into the cation exchange capacity. So this is where I wanted to go with this next part, is what is the composition of these clay minerals, and how does that impact how much exchange do we have between them? And this is impact. So all these things all work together. So the acids, all the different parts to it. So we have these clay structures that are held together by different ions. So what are clays generally made out of? Is silicon, oxygen, and aluminum. Okay, so this is their basic composition of clay minerals. Different ratios, different things that are inside of them. I took a whole class called clay mineralogy, and I spent a whole semester just talking about all the different chemicals and minerals that go into clay and their different properties, and because clay becomes very important in so many aspects, and I've kind of mentioned some of it before, but clay becomes so important. But if we take clay down and we look at just clay, it's generally just oxygen, silica, and aluminum, and they come together in different ways, and they form all of our different types of clays that are out there. We talked about when we grout in wells, remember that? So that's a clay that we use. We use clay for making pots. We use clay for a lot of things. So clay is really important. Soils also contain a lot of organic material. So these are the complex organic materials that are also found in soils. So most soils, we can find clay, we can find organic material. Organic material gives us that black colors that we see in the soil, but it is so complex, and so we can get what are the easily degraded organic material breaks down really, really fast as soon as it gets into the soil. Remember we talked about the O horizon? Well, as soils get older and stuff like that, you break down, and then you get into these more recalcitrant type of organic molecules that are really big for microorganisms to eat. And so the acids help to break them down. The organisms chew away at them, but they're very, very complicated organic material. And usually when we talk about soils, we usually just talk about humic acids and fluvic acids. And what we'll do is we'll take to a soil, and then there's these standard methods. Again, there's standard methods for all of this, where you put it into your soil and you look at the amount of humic and fluvic acids that are in there, and by different extractions. And because they're so complicated, we don't actually say how much of like one particular type of organic compound. We kind of just lump them all together. So what are some of the factors influencing organic matter accumulation into our soils? Well, topography. So remember we talked about the low-lying areas here. Hopefully tomorrow, I'm hoping tomorrow morning, that's Thursday, I'm going to take I was going to take a road trip around the area and kind of talk about some of these things and give you guys like a road trip view of the soil activities that are in this area. So the topography, the low-lying areas of this give us more organic material, because those were where intersected the water table, and so we get this accumulation. So that'll impact it. what type of vegetation that you have inside of there. So I mentioned before about the U of I having a test field where they have organic material where they've planted for 100 years, and they've also left things in prairie, and they could talk about the different vegetations and the amount of organic material that's inside of there. So native vegetation really adds a lot of organic material to your soil. The climate, so as climate is changing, we're going to be changing how much organic material gets into there. We get accumulations of organic material, and we've talked about this multiple times in the class, and climate is one of the big things that impacts it. So how much time does it, so one of the reasons, like when we talked about Cancun, and when you talk about like deforestation in very, very hot climates, is that what happens is one of the reasons that soil hasn't really accumulated too much in Cancun is because there's two reasons. Well, one of them is, well, there's multiple reasons. I'll get to them, but the one I'm going for here is that when that organic material lands onto the ground, it's so warm, and it's warm all year round, that it just breaks down always completely. It doesn't have a time for that accumulation. One of the reasons we have so much soils around here is we've had that time for it to accumulate, and so it makes for really productive soils. In Mexico, anything that lands, especially in Cancun area, it lands on the ground, on the rocks, it just degrades completely away, and so you don't get that time for accumulation of soil. So that's why a lot of times when they go through in these very tropical locations, and even though you have these really dense forests, and they clear cut the area, then they plant for a couple seasons, and then the soil is completely gone, because it takes thousands of years for the accumulation. But they're very warm, they don't get that organic material forming there. They also don't get soils because the limestone that's in Cancun is very clean. So one of the other ways that, as we talked about acid rain, and we talked about acids coming in there and weathering away like limestone, because when you take acids and you have limestone and you interact them, you form CO2 as a gas. It's actually kind of fun to take, limestone, drop acid onto it. Geologists do this all the time, drop acid, and then it bubbles, and then we know it's limestone. Well, as that's happening, it takes all the carbonate and forms CO2 out of it. Well, if you have a very dirty limestone like we've got around here, you'll get that soil, the old clay particles that were inside of the limestone accumulating. But in places like Mexico, where it's a very clean limestone and it doesn't have a lot of clay particles into it, when it weathers away, there's nothing left. So that's another reason there's not a lot of soils there. And so even though these places have very heavy forests, doesn't mean they've got great soils. And so that's part of the problem. They're also very weathered, things that we talked about. So climate is a really big factor in the soil. So this is why we're kind of in this beautiful, glorious place for when it comes to soil. Time, we need, like we talked about, the last glaciation, the last glacial maximum that's in here. The soils are taking thousands and thousands of years to accumulate to make these beautiful soils. So it takes a lot of time in order to be able to create the soils. And we've watched a couple of videos and we've talked about it, depending on the time that you're doing it. And then also the microorganisms and the other organisms that are in there. Earthworms, vertebrates, invertebrates, everything, microorganisms. There is more organic material and more organisms below the ground surface than there is above. I know, blow your mind. But think about it, all the roots and animals and everything like that. We know that there's more organisms below the soil than there is above. And it's just, we're very centric on us because we live here, but soils have so many microorganisms and so many different things that are inside of it that help to create that soil. And so like my mom, she lives up in Sycamore, and they bought a new house that was over there. And what they would do is when they built the houses around here, the black soil, the top soil, that black, that A horizon and that O horizon, that area there, they would take that A horizon off and they would put it into a big pile. They'd build the houses on the B horizon, and then they would bring back and fill up your yard with the A horizon so that you would have the topsoil in your yards. And so they would make these big piles of it. Well, when they would get rid of these, when they put these piles over in the corners and stuff like that, a lot of these organisms that we're talking about here would go away. Well, it took a long time. It took about 5 years for her to start having earthworms coming back into her soil and for her soil to really become back to alive like my soil is in my yard. It took a long time for all of that life to come back to it, and then it started to become healthier. So it really depends on the organisms that are in there too. So yeah, that's one of the big things. So forest soils, if they're well drained or poorly drained, this is the percent of organic material that's inside of there. So 0 to 8, 0 to 24. So how much we get a lot of poorly drained soils. We'll get a lot more organic material at the top because it allows it for it to accumulate. If it's very well drained, you'll get the organic material throughout the whole entire soil. You need that accumulation in order to create that organic. Create that organic. You need to have those clay particles that help to hold that water in there. Now, because that's what gets organic, but certain types of plants don't like that. I mean, you have to think about your plants and all of this stuff. It's just so beautiful. It's just really interesting. Okay, so when we look at different types of soils too, we look at a prairie soil, which we've got around here. We usually have that A horizon, usually about 14 inches. It varies depending on where you are, but we get this prairie soils. We get this very thick organic thing. When we look at forest soils, especially with this very well drained, we may only have like a few inches. And so again, when we talk about the effects of native vegetation, it creates this beautiful organics. I mean, the root systems of our prairie plants around here can be 6, all these really, really deep root systems help to create this very thick, beautiful soil. While in forest systems, you might only get a little accumulation. So when we clear cut a forest, we may not get that much good agriculture. So here, prairies, great agriculture. Again, soil's beautiful. You guys all should take a soils class. Sorry. As you can tell, I like soils, I like water, I like geology, that's why I teach this class. Okay, so the importance of soil organic matter on physical and chemical properties. It improves the physical condition of the soil, so it allows for good aggregates of the soil particles, the plants to form. So we talked about those clods, and those clods are in the plowed parts, those aggregates to form, which are very important for the structure of that soil, which impacts what plants can grow in there, animals. The whole thing is impacted. It also increases water infiltration, allows for water saturation by acting as an absorbent. So what it does is this organic material will absorb some of that, and it absorbs it. And we talked about that field capacity. Remember, we talked about field capacity, and we talked about availability and wilts and all that stuff yesterday or last time. Well, when you do that, the organic material helps to hold some of that in so the plants get it for later on. So it acts that way. And improved soil tilth allows for uniformity of soil aggregation in proportion of plant, animal, and mineral residue present. So it impacts the whole of the water quality that's inside of there. Let's see.